Okay, so this is another circle theorem proof video. What we're going to focus on this time is how do we prove that this angle up here is the same as this angle down here. So let me just move this for a moment. This is how it's normally drawn in the textbooks. Usually this line is horizontal, and this line up here, this doesn't normally exist, but just on this tool GeoGebra, when you draw a tangent, it tends to draw two tangents that bisect at some point. So we can kind of forget about this line, but I don't know if I'm sure if I delete that, it will delete both of them. I can try. I can have a feeling that, yeah, it's going to delete both of them. Anyway, so this angle is equal to this angle. So let's just show that it is the case. Well, actually, no. Let's show it at the end. Let's start off just by proving it. Okay, so basically I'm showing that x is equal to y, and the way that I'm going to do that is I'm going to start off by getting a connector line, which, where are we going to find that? Segment, okay. And I'm going to join this to C. So W is the center point, and I'm also going to join W to B1 down there. And because both of these are radii, so W to C1 and W to B1 are both radii of the circle, then the triangle WC1 and B1 is an isosceles triangle, which means this angle up here and this angle down here is, well, they're the same, right? So let's call those angle A, okay? So that's angle A. Okay, and we're also going to chop this equilateral triangle into two, like that. And we're going to label these two angles here. They're going to be the same as each other because they're just chopped an isosceles triangle in half. So that we're going to call that B. So that's B and that's B. And of course, we can say that that's a right angle. Okay. Okay, so the next thing that we can say is that because W to B1 is going from the center to a tangent, then going by another circle theorem, which I've proved in a previous video, then that angle there would be equal to 90. So in other words, A plus Y is equal to 90 degrees. And if we look at this triangle that we drew with the dotted lines and the B and the A, then we can see that just take one of the right angle triangles there, and we can see because that's 90 degrees, then B plus A must be equal to 90 as well, because 90 plus B plus A must equal to 180, so B plus A must be equal to 90, because then you add 90 and that adds up to 180. So we've got, let's rearrange that to say A plus B rather than B plus A, because then we can more easily see the next thing that I'm going to say, which is that B must be equal to Y. So therefore, B must be equal, B, what I was trying to say there is that, how do I move this around? Oh, great. Looks like I'm just going to have to delete it and write it again. I'm still learning how to do this. Right, okay, so therefore B is equal to Y. Okay, so we're getting closer, not quite there yet. So what rules have I used so far then? I'm applying other rules to prove this one. So let's just zoom out here and see some of the other circle theorems I've got. So I've used, I haven't actually written the other one down, but I've used one of them with the tangent then. And now I'm going to use this one here. So this, no, not this one, this one. This angle is double that one, okay? So let's see if we can spot that in what we've just drawn here. Can you see that C1 to W to B1 is going to the center, and then from the same side, C1 to D1 to B1, then X must be equal half of this angle here. In other words, 2B is equal to X. So, well, you might be able to see the rest of it. I'll just get my pen. So, in other words, 2B is equal to X. Therefore, B is equal to X. And if B is equal to X and B is also equal to Y, then X is equal to Y. Okay, so let's just recap there. How did I get what did I do first? I drew some line segments from W to C1 and from W to B1, and I drew a dotted line there and identify that this was an equilateral triangle, so I drew a dotted line there, and so we've got two identical right angle triangles. This angle would be the same as this angle, call that A, and then I said that A plus Y must be equal to 90 degrees because this W to B1 has to be perpendicular to this tangent using a previous circle theorem. So we had A plus Y is equal to 90. And using these triangles here, we can see that A plus Y is equal to 90 and A plus B is equal to 90. Therefore, B must be equal to Y. I then notice that this is going to be double that, and that's 2B. So 2B is equal to X, so B is equal to X. So therefore, B is equal to X and B is equal to Y, so X is equal to Y, and that's what we were trying to prove. So that's it.